Hey everyone, today I'll be going over 1572 matrix diagonal sum, Leetcode problem. Very easy. Uh, Basically, they give you some matrix. The rows are equal to its column, so it's an n by n matrix. We sum up the diagonals. So the key here, it seems like very simple, but the tricky part is if it's an odd matrix, meaning like n by n is odd, we don't want to double count this middle. We only want to count it once. So that's just something to note. So basically we have this. Let's go ahead and get the n of this matrix. And then what we want to do is we want to go up to n. And that's all we have to do. Let's also keep track of some sum. We know we're going to return the sum. Now, basically what we want to do is we want to sum up the diagonals. So to get this top left to bottom right diagonal is very easy. So all you do for that is, and we want to do that, all we do for that is we go I of I. The reason why this works is because, 0, 0, 1, 1, 2, 2, and then that'll be that diagonal. This other one's tricky because we have to, for row wise, we have to go from the back. Column wise, column wise we have to go from the back. Row wise we go from the front as normal. So what we can actually do is just add. So as I said, row wise we start off at 0 as well, so that's going to be I. But for this one, we actually want this to come from the back. So it's going to be n minus 1 minus I. Now we do this because basically, like at the beginning, it should be 2. The length is 3. 3 minus 1 minus I would be 2. Yeah, you get the point. So we just want to do it from the back. We're going to go like this. Let's run this, and I'm going to show you why it's going to be wrong. Let's see here. Should be wrong. Yeah, so 30. If you notice, the difference is 5, and that's because we double counted this 5. Because we're actually, when we get to here, on both diagonals, we double counted that 5. So what we actually want to do is rather than just returning the sum naively, let's check if it was odd. So let's do n, let's go ahead and do n mod 2 equals 0. So this is the condition. And basically this means, is it even? If it's even, yes, we can just return the sum. It's going to be fine. And it won't overlap if it's even. You can see it with this example here. It's because the diagonals never overlap. If it's not even, if it's odd, we actually have to subtract something. So we're going to go sum minus. And what are we going to do? We're just going to take off that middle cell. So mat, and this is going to be n2, n2. And this will be the exact middle of the cell. So basically, is it even? Just do the sum. If it's odd, we have to take off 1 because we double counted it. Now let's run this. And this should be good. Let's go ahead and submit this. And looks like that's good. 100%. Let's talk about time complexity, space complexity. Space is easy. That's just constant because we're not actually doing anything besides just some variables there. So let's go to space. Space, we actually go through this array once, really. This could have been like 2 for loops or whatever. It really doesn't matter, but I do know it's n. If you really like it, we're just going across the diagonal and it's just one loop and it's n, so it's really just n, where n is the n in the n by n matrix. So yeah, space, time, and yeah, I hope this made sense. Thank you for watching.